Hey guys, welcome. Yeah, so recently I shared a fun SHSAT geometry problem, and so appropriate that here I share a fun, challenging SHSAT Algebra problem. Yeah? Okay, if you care, the SHSAT, I believe, stands for Specialized High School Assessment Test. And what it is it's a test that you take to get into the handful of good public high schools in New York City. Yes, handful. So I'm suggesting that most of them are, whatever. Okay. So here's what you're told. You're told that NM is a 2-digit number, as is MN, and when you multiply them, you get the 3-digit number NKN. And additionally, you're told that n plus k is equal to 7, and the task is to figure out the 2-digit number mn. Last but not least, you're told that n, m, and k are distinct numbers, and none of them are 0. Yeah? Okay, so how do we do this? Well, just like the SAT, the SHSAT is a timed test. And so, efficiency matters. So, as a good test taker, what you should do in this problem is just go through the answer choices. I believe one of the answer choices was like 12, and another one was like 21, and another one was 13, and yeah. So go through the answer choices, and there's at least one more answer choice. Okay. All right. So if we went through the answer choices, say we try B, then we have 21 times 12. So we're saying that NM is 21, so this is MN, right, the 12, right, and if we multiply them, if we times them, as some students like to say, then we get 2, 4, and then what is it? We get 1, 2, so it'd be like 2, 5, and 2, so 252, and so this here is supposed to be like N, KN, so like N is 2, and so that stayed 2 and 2, and then k is 5, and the constraint on k is that when we add it to n, it's equal to 7. Well, 2 plus 5 does equal 7. What a guess. Okay, no. Alright, so how do we do algebra to solve this is the question, right? Because, in this video, we don't care as much about the time, right? Okay, so here's how you can do algebra to get to the same place, which is to pick out the correct answer. Again, the algebra is perhaps too long for it to be a practical approach to solving this problem on an actual SHSAT. But to say that NM is a 2-digit number is to say that we could write it as 10 times n plus m. For example, if our 2-digit number is 73, that's saying 10 times 7, 70, and then plus 3. That's what 73 is, right? Okay, you buy that? Fine. So then, by the same argument, mn has to be equal to 10m plus n. And then we multiplied these two numbers. So nm times mn makes m&m, or nnm. Okay, equals 10n plus m, and then 10m plus n, right? Some FOIL action, right? It's actually the distributive property. I dislike FOIL. Yeah, so if we apply the distributive property, we get 100 nm, right? And then we get 10n squared plus 10n squared plus 10m squared plus nm. And we know that this is supposed to equal the 3-digit number nkn, right? Okay, so we have a little bit of cleaning up we could do. So 100 nm plus 10 times n squared plus m squared, right, plus nm is equal to, what does this 3-digit number look like? Well, it would have to be 100n using the same kind of interpretation that we wrote here. It would have to be 100n plus 10k and then plus n, right? This here is that 3-digit number, right? Okay, so I need space. So now this here has to correspond to this. So comparing this to this, we see that nm has to equal n. So nm has to equal n. And nm is like a single digit number because, well, it's like 100 times that single digit number will have to equal 100 times this single digit number, right? So now, right now, nm, when we multiply them, turn into the single digit number this. That's what we're saying. And we have a consistent statement here at the end. nm has to equal n. That's the same thing as here. So again, comparing this to this, we get nm is equal to n, but comparing this to this, we again get nm is equal to n. Okay, I won't write it twice, once is sufficient. But then comparing the middle, we see that n squared plus m squared, right, will have to equal, so n squared and m squared here are multiplying 10, so they have to equal what's multiplying 10 here, which is k. All right, cool. But then in this part, we are told that n plus k is equal to 7. So then here, we should try and get rid of the k here, right? And so then we can see that k is equal to 7 minus n, right? So I can replace this k here with 7 minus n. Yeah? Okay, cool. All right, and furthermore, notice that nm having to equal n, whether it's like by comparing this to this or by comparing this to this, leads to only one conclusion, that m has to be equal to 1, right? So we come here and in place of m, write a 1, so that means we have n squared plus 1 squared, so plus 1 is equal to 7 minus n, right? And so this is a quadratic in n, so if we bring everything to one side, it would read n squared, and then it'll have to be plus n minus 6 is equal to 0. Now I don't need this, but I need the space. So where to from here? Well, some factoring action, right? So some factoring action would say that we write n plus 3 times n minus 2 equals 0, from which we get n is equal to negative 3, or n is equal to 2. Ah, cool.